we're moving into graphing linear functions. So we've talked about linear functions, we've graphed them a little bit, but we have to talk about the different forms that we could write a linear function in. I want you to think about if you have a dollar bill. If you have a dollar bill and you go up to a cashier, are you able to convert your dollar bill to 4 quarters?
Yeah.
Yes. If you have 4 quarters and your friend has a dollar bill, do either one of you have more money than the other person? No. What's the difference? You have them in different forms, right? So that's what we're going to be learning today and next class is different forms that we could write linear functions in. So the form we're going to learn today is called standard form, not slope-intercept form. We'll talk about slope-intercept form later on in the next day or couple days. We're going to talk about standard form first. So standard form of a linear function is ax plus by equals c. And you'll see the little note I wrote to the side says that a, b, and c, which I've highlighted in yellow, will be replaced with numbers. So it'll be some number times x plus or minus, it could say minus, some number times y is equal to a number. If it is written in that way, we call it standard form. So if you look at this, I'm going to zoom in. I'm going to make this up right now, but let's say you had an equation that said, let me turn my pen on, sorry. 3x plus 5y equals 30. Do you see how it's a number times x plus a number times y equals a number? That would be standard form. As I was saying, this is standard form, right? What is the a in this equation? 3. The b is
5.
And the c would be 30, right? Now, when something is written in standard form, it's easy to graph it, and I'm going to show you how. Before I show you how to graph it, we got to talk about some concepts. The x-intercept and the y-intercept. What does the word intercept in general mean?
Intercept, get in the way, cross.
Get in the way, where two things cross over each other, right? So if I say the x-intercept, I'm talking about where the line crosses the x-axis. So in this case, this would be the x-intercept right here, right? Where it's crossing over the x-axis, that black dot right there. And then the y-intercept would be where the line crosses over the y-axis. Do we agree with that? Now think about this. If I just drew a point on a coordinate plane, is that enough to create a line, just one point? How many points do you need to create a line?
2.
At least 2. If you have 2 points, you could connect them and create a line, correct? So, all right, so what we're going to do today is we're going to figure out the x-intercept and we're going to figure out the y-intercept. And if I know the x-intercept and the y-intercept, then I can connect those 2 points and create a line. So the question is, how do I find the x-intercept and the y-intercept? And I'm going to show you how to do that. But before I do that, I want you to look at the y-intercept. If you look at the y-intercept, where this graph is crossing over the y-axis. Now, this isn't numbered. However, do you agree that the ordered pair, is going to be some 0, some number?
Yeah.
Because the y-intercept always starts with a 0, right? I want you to think about what would you call this ordered pair, the y-intercept, now that I put these little marks? Can you guys count for me, please?
5.
This is at 5 on the y-axis. So would you agree that what would the ordered pair say then? 0, 5, right? Do you see how the x value is 0? Since the x value is 0, what if the y-intercept was somewhere else? Would the x-intercept be anything different? If the y-intercept, I'm making this up, was right here, would the x value be any different?
No.
No. What if the y-intercept was down here? Would the x value be any different? What do we know is true about all y-intercepts? The x value will be not just the same, what will it be? What would the ordered pair of this one be if I crossed over here? 0, 2. What if it crossed over right here? 0, -1. What is the same about all of these ordered pairs? They have a 0 where? As the x value. Y-intercepts will always have a 0 for x, no matter what, because it can't cross the y-axis without having a 0 as the as the coordinate for x. Now, if you think about an x-intercept where it crosses the x-axis is always going to have a number for the x value and a 0 for the y value. If I said, okay, who could tell me what that ordered pair is now that I just put those markings? If you look at this x-intercept, it's crossing the x-axis where? At 8, right? Which the ordered pair would be 8, 0. Do you agree with that? Because the x comes first and then the y. If it was crossing over, let's say, here, what would that ordered pair be? 2. A 2 isn't an ordered pair. 2 is just a number. What's the ordered pair? 2, 0. Is there any x-intercept that would have anything other than 0 for the y value? No. All x-intercepts will have a 0 for y. All y-intercepts will have a 0 for x. That becomes very important when we talk about how to find the x and y-intercept. You need to understand that concept. So, with that being said, let's look at this first equation. It says use the intercepts to graph the equation 3x plus 4y equals 12. My first question to you is that in standard form? Yes, it says ax plus by equals c. The a is 3, the b is 4, the c is 12, correct? So this is what we're going to do. Do we agree that if it's an x-intercept, what do we know is true about all x-intercepts? X-intercepts means where it crosses over the x-axis. No, it doesn't start with the 0. It's the ordered pair for any x-intercept will be, where will the 0 be? The y value, right? And then for the the y-intercept where it crosses the y-axis, isn't it going to be 0, a number? Now, with that being said, we could do what we call plugging in zeros to find the x-intercept and the y-intercept. So you'll see my little note right here in that arrow says plug in zeros. So I'm going to take this equation, 3x plus 4y equals 12. First, I'm going to plug in a 0 where it says x. So I highlighted the x, and I'm going to plug in a 0. That means 3 times 0 plus 4y equals 12. Now I have enough information to solve for y. Since 3 times 0 is 0, I could cancel that out, cross it out. I have 4y, positive 4y equals 12. So to get rid of the 4 that's being multiplied to y, what do I have to do? By and divide the other. Whatever you do to one side, you got to do on the other side, right? So what does it say? Y equals what? 3. If y equals 3, that means the y-intercept is 3. So I'm going to go to the y-axis, and where it says positive 3, I'm going to put a point. Now I'm going to go back, and this time I'm going to plug in a 0 for y to solve for the x-intercept. We're plugging in these zeros because we know that the x-intercept will always have a 0 for y, and the y-intercept will always have a 0 for x. So now I'm doing the same thing, but I'm plugging the 0 into the y spot. So 4 times 0 cancels out. I'm left with 3x equals 12. How do I get x by itself? By 3 on both sides, right? What is 12 divided by 3? So that means my x-intercept is at positive 4. So I put a point at 4. And then the last thing I do is what? What do you think? Do I have enough information for a line now that I have 2 points? Yeah, so I will, oops, my bad, sorry. I will connect them to make a line, right? And I'll put arrows to show that that line would keep going. So if I asked you the ordered pair of the x-intercept, what's the ordered pair of the x-intercept? No, that 4, 3 would be right here. That's 1 point, 4, 3. We have 2 different points. The x-intercept would be what? 0, 3. No, that's the y-intercept. The x-intercept, where it's crossing the x-axis. 4, 0. And what is the y-intercept going to be? Say it again. Well, we know what it is. What is it? 0, 3. On the test that we take, you will need to be able to write what the ordered pairs are. So 4, 0 is the x-intercept, which makes sense. Didn't we say all x-intercepts will have a 0 for y? And then the y-intercept is 0, 3. And I said all y-intercepts will have a 0 for x. Yes. It's an emergency. All right, we're going to do another one. Really quickly, what's the a in this equation? Definitely not the a. 2. What's the b? It's not 1. It's not y. What's in front of the y? Negative 1, because there's a minus sign. And what's the c? 4. I just want you to be aware of that. Okay. If I wanted to graph this, is this in standard form? Yes, it is. Okay. I know the a is 2, the b is negative 1, the c is 4. If I want to graph this, what would I do to graph this? So I'm plugging in zeros. Now, it doesn't matter which one you plug a 0 into first, but you need to be careful. If I plug in a 0 for x first, then I'm finding the y-intercept. When I plug in a 0 for y, I'm finding the x-intercept. So I'll plug in a 0 for x first. So I'll say 2 times 0 minus y equals 4. And now I will solve for y. So 2 times 0 goes away. This doesn't say y equals 4. It says negative y equals 4. What do I do to get rid of that negative, which we said was really a negative 1, right? What am I going to do to get rid of that negative 1 in front of y? Divide by negative 1 on both sides, right? What is 4 divided by negative 1? So my y-intercept, don't get confused and put this on the x-axis. The y-intercept is negative 4. So I'm going to go to the y-axis, and I'm going to go to negative 4 and put a point. All right, now I'm going to do the same thing, but this time where am I plugging a 0 into? We just plugged in, so the y. So it says 2x, I'll leave x, but I'll say minus 0. I'm plugging in a 0 for y this time equals 4. Isn't 2x minus 0 just 2x? So I'm left with 2x equals 4. Divide by 2 on both sides. What does x equal? So the x-intercept is at 2. Do I have enough information now to graph this line? Yes, I connect these with a line. If I asked you what the x-intercept was, what's the ordered pair of the x-intercept here? 2, 0, x value, comma, y value. What about the y-intercept? 0, negative 4, right?
Wait, why did you put the red dot on that 4 and not the other?
Because the y-intercept is talking about the y-axis. If you put it on the negative 4 on the x-axis, that's the x-intercept, and the x-intercept is positive 2. Okay? All right, I want you guys to try this one. All right, so you'll see that I have started by plugging, I did 2 different equations. First, I plugged in a 0 where it says x, and then I plugged a 0 where it says y. So I'll start with the one where I plugged in a 0 for x. So 0 plus 3y means just 3y, right? So 3y oops, wrong color. 3y is equal to negative 9. When you divide by 3 on both sides, what does your y-intercept end up being? So the y-intercept is negative 3. Okay, and then the x-intercept, I'm going to do 3 times 0, which is 0. So x plus 0 is just x. I don't even need to solve for x now. It's already by itself. What is x? Negative 9. So the x-intercept is negative 9. So when I go to graph these, where am I putting a point on the y-axis at? So right here on the y-axis, I put a point at negative 3. And then on the x-axis, I put a point at negative 9, which would be right here. And you can see the line looks something like, I'm going to have a hard time connecting these right now. Something like that, right? If I asked you the x-intercept, you would say negative 9 comma 0. The 0 is in the y spot. If I asked you the y-intercept, you would say 0 comma negative 3. You can see that the x-intercept has a 0 for y. The y-intercept has a 0 for x, right? Okay, now we have to talk about horizontal lines and vertical lines. Horizontal means left and right. This one is a horizontal line. Vertical is up and down. This is a vertical line, okay? If you are writing an equation for a horizontal line, it's always going to be y equals whatever number it's crossing through on the y-axis. Because isn't it crossing through the y-axis? If you look at this graph here, this blue line that I just went over in black, this line, is it crossing the x-axis in any way? No. So we don't write x at all. We write y equals and whatever number it's crossing at. So if I said, where is it crossing the y-axis here? At 4. So since it's a horizontal line, the equation would be y equals 4. It's just y equals a number. If you look at this one, which is a vertical line, the vertical line, does it cross the y-axis at all? All right, so this vertical line doesn't cross the y-axis at all. It only crosses the x-axis. So the equation for a vertical line is going to be x equals a number. Where would you say this one's crossing over if I did that? Where is it crossing the x-axis at now? 3. So the equation would be x equals 3. Okay, so horizontal lines, it's always y equals whatever number it's crossing the y-axis at. For vertical lines, it's always x equals whatever number it's crossing the x-axis at. So for example, if I said I'm graphing two different things, y equals 4 and b equals negative 2. What kind of line is y equals in just a number? Is that going to be a vertical line or a horizontal line? Horizontal line. Okay? This is where kids get confused because they see y equals, and when they think of y, they think up and down, so they think it's a vertical line. If it's saying y equals 4, go to the y-axis and go to 4, which is right here, and draw a line through it, meaning like this. What kind of line is that? Horizontal. That right there is y equals 4. If I said x equals negative 2, what kind of line is x equals negative 2 going to be? I heard someone say it. A vertical line. Meaning I'm going to go to negative 2 on the x-axis, which is right here, and draw a vertical line through it. So the red one is x equals negative 2. The black one is y equals positive 4. Okay? Last thing we're going to do is a word problem. It says you're planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in two sizes. Small tables that seat 6 people and large tables that seat 10 people. They give you this equation. You're lucky they give you the equation. Sometimes you have to come up with the equation. But they give you this equation, 6x plus 10y equals 180. Doesn't that make sense? Didn't we say one of the tables seats 6 people and one of the other tables sits 10 people and you're seating 180 people in all? So that's your equation. What is x representing then here? Well, this number in front, 6, is a, but I'm asking, what does the x represent? What number is in front of x here? 6. What did we say 6 was for? If you read the word problem, what does it talk about? It says 6 what? For which one? What kind of table? No, it says small table seat 6 people. So x is going to represent this small tables. Thank you. 6 people per small table. What is the y going to represent? The large tables. If it says 6x and 6 people are at the small tables, so x is the small tables. If it says 10y and 10 people could fit at the large tables, then y represents the large table. So x is the small tables, y is the large tables. It says graph this equation. If we wanted to graph this, tell me what we would do to graph this, just like every other one. Plug in a 0 for x, and then plug in a 0 for y. If I do that, if I plug in a 0 for x, 6 times 0 plus 10y equals 180, right? Divide, that goes away. Divide by 10 on both sides. What's 180 divided by 10? 18. Now do the same thing, but plug in a 0 for what now?
10.
Not for 10. You can't plug in a 0 for 10. 10 is already 10. Where am I plugging a 0?
Y.
For y. All right. 10 times 0 goes away, and I have 6x equals 180. If I divide by 6 on both sides, 18 divided by 6 is 3. So 180 divided by 6 is going to be 30, right? So my x-intercept is at 30, my y-intercept is at 18. Those are kind of big numbers, and I'll show you that they've already graphed it for you. They went by, it looks like 2s instead of 1s on the x and y axis. Do you see that the y-intercept is at 18 like we said it was supposed to be? And the x-intercept is at 30 like we said it's supposed to be, right? That's great. They graphed it for you. Now, it says interpret the intercepts, meaning we need to talk about what this means. What do you think the y, what did we say y represented in this equation? No, the number in front of y is the b. The large tables, right? The number of large tables. The number in front talks about how many people could fit at each large table. Y represents the number of large tables you're going to get. What does x represent? The number of small tables, right? So if we look at this y-intercept, which is 0, 18, what is the x value of this ordered pair? The x value of this y-intercept is 0, right? And the y value is 18. So didn't we say the x represents the small tables? So if I have an ordered pair 0, 18, and we know that the x is the small tables and the y is the large tables, what is this telling me? If you have 18 large tables, how many small tables would you need? 0. No, you would need 0 small tables. 0, 18 means if you got 0 small tables, you would need 18 large tables to fit 180 people. The x-intercept, which is at 30, 0, isn't 30, 0? Isn't the x value here 30, which we said is small tables, and the y value is large tables? Isn't this telling you that if you got 30 small tables, you would need 0 large tables? So that's the intercepts. Is that your only option, is to either get 18 large tables and no small tables, or 30 small tables and no large tables? Is that your only option, to get either only large or only small? Could you get a mixture of the two? I want you to look at this line. I want you to find some perfect points, meaning where it crosses over perfectly. Would you agree that's a perfect point?
Yeah.
Okay. This looks like another perfect point. And that might be the only other 2 perfect points. Who could tell me what this ordered pair right here is? No, 12 is right here. 10, 12, right? So if this is 10 comma 12 and the X represents the small tables and the Y represents the large tables, isn't that telling me you could get 10 small tables and 12 large tables? This ordered pair right here is 20 comma 6. Doesn't that mean, tell me what that means actually.
That you can have 20 small tables.
20 small tables and 6 large tables would fit 180 people. So every perfect point on this line is a combination of small and large tables you could get that will fit the amount of people that you need to fit. And again, the intercepts, the x-intercept and the y-intercept would represent how many tables you would need to get if you're only getting large tables or if you're only getting small tables. Okay? Do we understand the lesson?